Hello, geometry students. This is Mr. Zacek, and we are in Unit 2, Lesson 3. Now, we're going to split this one up into a couple different videos. We're going to call this Lesson 3A and 3B. Same thing here. And you're going to notice that I've got, for the first part of this at least, things are going to be filled out. So I'll kind of move the cursor around to show you what I'm talking about. So what we're trying to do here is build a bridge between algebra and geometry and this concept of proving things and building a foundation for it. And we're going to build on some stuff that we've already done before. So we've got the addition property, and what the addition property, now notice up here it says properties of equality. So what we're talking about is when we have a property of equality, we're talking about, if we do whatever we do to one side of an equation, we do to the other side. So it says if A equals A and B equals B, then A plus B equals A plus B. So if you put some numbers in there, if 2 equals 2 and 3 equals 3, then 2 plus 3 equals 2 plus 3. And what we'll start using that with in segments when we're doing like a segment addition or something is if AB equals AB and BC equals BC, then AB plus BC equals AB plus BC. Just one detail to note here. Notice that when we use the equal sign with a segment, we don't put the segment bar over the top of it. And that is the length. That was one of the questions in our first problem set that people misunderstood, that you're talking about a length or a distance when you don't put the bar over the top. All right, so very similar to addition is subtraction. If A equals A and B equals B, then A minus B equals A minus B. So here's an example of how we would use that. X plus 2 equals 8. So we're going to subtract 2 from both sides. That's why it's a property of equality. And then the result of that is that x equals 6, because we subtracted 2 from one side. 8 minus 2 is 6. Multiplication property, if A equals A and B equals B, then A times B equals A times B. So we do that when we have an equation with a fraction in it, like x divided by 3 equals 5. We would multiply both sides by 3. And 3 times 1/3 gives us 1x, and 3 times 5 gives us our 15. Division property, if A equals A and B equals B, then A divided by B equals A divided by B. And we see this here, when we're solving 10m equals 80, we're going to divide both sides by 10, and the result of that would be m equals 8, and the reasoning would be the division property of equality. All right, so that's a lot of like algebra solving. We've already done some of that this year, so should be kind of familiar to us. All right, new one. This one we are going to use a lot. Okay, it's very, very popular, called the reflexive property. And it basically says something is equal to itself, or we could do it with congruent as well. So 5 equals 5, or AB is congruent to AB. All right, and obviously that's very obvious, but we need to give a reason for some things that seem obvious. The symmetric property allows us to switch sides of the equal sign. So if we have like -4 equals x, then x equals -4. And situations we would use that in is like if we're solving an equation and we end up with a variable on the right side of the equal sign, we might use the symmetric property to rewrite it over on the other side. But so the symmetry, you just flip sides. Okay. Now a couple more. The transitive property. Transitive property says if A equals B and B equals C, then A equals C. So kind of when I think about the transitive property, I sort of think about like this and this cancel each other out. So here's an example. If x equals 2 and 2 equals y, then we know that x equals y. The substitution property, the measure of angle, ABC equals 142, x equals 142, so then the measure of angle ABC equals x. So just this little note over here that these are similar And what I mean by that when I say they're similar is they very often can be used interchangeably. That we can either use the transitive property or substitution. Transitive is a little more specific, so if you're not sure, substitution is a better avenue to go with, but you know, they both can work in a lot of situations. All right, then we have the distributive property here, and obviously we think about the distributive property like the dolphins jumping over here. But the one thing to note is you can also give it another color. You can also go from the right side back to the left side. And that's the distributive property. We might think of that from algebra as like factoring out a common factor, but that's actually what we're doing when we combine like terms, when we're adding radicals, or like 2x plus 3x, those type of situations. Okay, so if we do combine like terms, we do that on one side of the equation, so that's not a property of equality. And then, so equality, again, it has to do with an equal sign, but there are several of these that we can use with congruent symbols as well. Reflexive, symmetric, and transitive properties have corresponding properties of congruence. So instead of saying like the reflexive property of equality, we could write the reflexive property of congruence. And in general, we're not going to worry about that last little tail bit of it. We're just going to simply say the reflexive property or the symmetric property. Okay, so let's go and do the back of this page here. And let me see if I can pull up a little screen here so I don't overwhelm you with all this writing. So name the property that justifies each statement. All right, let's walk through this here. If A plus BC equals DE plus BC, then AB equals DE. Okay, so I wrote it up here again just to help, you know, us kind of see what's going on here. AB plus BC equals DE plus BC. How do we get to AB equaling DE? Well, we subtract BC from both sides. Those cancel each other out, and we're left, that's the subtraction property. Okay? The measure of angle ABC equals the measure of angle ABC. That's the reflexive property. Anything equal to itself. When I think about the reflexive property, think about like looking in a mirror. You get that mirror image. So we're going to use that a whole lot. If XY equals PQ and XY equals RS, then PQ equals RS. Okay, so that could either be, you could either call that the transitive property, or we could call that substitution. So property, either one of those would work for that. Essentially, we know they both equal XY, so we're replacing, I could think of like I'm replacing this XY with PQ. That would be a good way of thinking about it. Okay, so how do we get from here? If X divided by 3 equals 5, then X equals 15. Well, since we're dividing X by 3, the inverse of division is to multiply. Whatever we do to one side, we do to the other. And that's where we get X equals 15, okay? And then if 2X equals 9, then X equals 9 over 2. That's the division property. So you see that we have those there. All right, so let's go through these and just kind of talk them out. I'm not going to write them out here, but we'll just talk through them. If 3X equals 120, then X equals 40. And that is the, say it out loud, that's right, division property. Okay, if 12 equals AB, then AB equals 12. That one's not as familiar. You might have to go back and look your notes, and when you see it, when you switch sides of the equal sign, that's called the symmetric property for number letter B, number letter. If AB equals BC and BC equals CD, then AB equals CD. That's the transitive property here. And just to illustrate one thing with the transitive property, I always think about it in this way. If AB equals BC and BC equals CD, I always think about it like that. Those two kind of cancel each other out, and we're left with AB equaling CD. Okay, so transitive property, again, we could use substitution. If y equals 75 and y equals the measure of angle A, then the measure of angle A equals 75. Again, transitive or substitution. I probably would just go with substitution property. All right, so deductive reasoning can be used when solving an equation. Each step can be justified with a postulate, property, or definition. Okay, so we're getting into the difference here between these three things right here. The difference between inductive reasoning, we talked about before, inductive reasoning is based on an observable pattern. We make a conclusion, and now we're into deductive reasoning when we're solving an equation. So find the value of x, and here's the key, justify each step. All right, so when we look at this, when we look at this equation, what we should be thinking about here is that these two angles form a linear pair. All right, so we want to kind of get that in our thinking, that this is a linear pair. They're on a line. What do we know about two angles that form on a line? They are supplementary. So let's just kind of walk through this here. Angle AOM and angle MOC are supplementary. Now here's the reason. If two angles form a linear pair, then they are supplementary. All right. So we see that right from the picture, that they form a linear pair. If two angles form a linear pair, then they are supplementary. Now what do we know about the definition of supplementary? That they add up to 180. So we can say the measure of angle AOM plus the measure of angle MOC equals 180. If two angles are supplementary, then they add up to 180. So if two angles are supplementary, then they add up to 180. Sometimes we say they sum to be 180. Now what are we going to do? Now that we've got these with the letters here, this is the step that people kind of have to work themselves into. They want to jump right into the algebra step, which is the next step, which we get by substitution. This is the one in our first quiz. A lot of people left kind of that step out. Please don't leave it out. So now we have the substitution property. All right. Then what are we going to do to go from this line to this line? Well, we're going to simplify. In parentheses, we might say combine like terms. Okay. That's not a property of equality because we're not doing the same thing to both sides. We're just combining like terms. Then we subtract 30. That's the subtraction property. And we divide by 3, and we get the division property. So we have found the value of x, and we have justified each step. Again, the key here is on learning how to justify. Okay, we got one more here. And what are we given in this case? We are given that AB bisects angle RAN. When we see that word bisect, we want to think what? Cut into two equal parts or two congruent parts. A bisector cuts things into two equal parts. That's one of the ones that's on our proof parts thing that we did in our last lesson. So first of all, we start off with our given. Angle or ray AB bisects angle RAN. That's given. Okay. And we say the measure of RAB equals the measure of angle BAN. If a ray bisects an angle, then it divides it into two equal angles. If a ray bisects an angle, then it divides it into two equal angles. And what I'm trying to show you here with these highlighters is that this first part of our kind of if-then, if a ray bisects an angle, I want us to notice that we've said that's true back here in step 1. AB bisects angle RAN, then it divides the angle into two equal angles. So the statement in step 2 is connected to the conclusion of this. The conclusion's the part that comes after then. So divides it, the angle into two equal angles. What we're using here is something called the law of detachment, which is a law in logic that kind of justifies this deductive reasoning. But I wanted you to notice that very often when we write these if-then statements, it's the hypothesis, that's the part that comes after the if, has to be connected back to a previous statement, and then statement 2, the conclusion of it, angle equal to an angle, that's the conclusion of our reason over here, okay? And if you have questions on that, we can talk more in person about that. Now what are we going to do? We're going to substitute. X equals 2x minus 75. That's the substitution property. Then in this case, they subtracted 2x, so the subtraction property of equality, and then we divide by -1, the division property of equality. Okay, so we're going to get through here. We've got a homework assignment, an assignment attached with this. So this is lesson 3A, and then you're going to continue with this. We'll come back with lesson 3B, but we've got an assignment before we get to that. All right, good luck. Please ask questions, and let's keep going.